member of the Research Committee of Central Escolar University, Mrs. Jane Cruz, the Junior Philippine Pharmacists Association Data Chapter Advisor, Ms. Mary Carching, thesis advisors, my fellow researchers, and to my co-pharmacy students, good afternoon. We are the 9 presenters of today's Pharmacy Colloquium. We are from the class of BS Pharmacy 4. My name is Maria Villaracha, and my co-researchers are Ms. Katie Viscas-Cavillo, Ms. Joy Grisel-Estrella, and Mr. Taylor Gymnasio. Our group had come up with this investigational study entitled Investigation of the Antibacterial Property of Fixed Oil from the nut of Pili, Canary Tobacco family Burseraceae. Pili oil is found only in the Philippines, where it is common in primary forests at low and medium altitudes in northern Luzon to Mindoro, Icao, Masbate, and Sorsogon in the Bicol region. The seeds or kernels of pili are edible nuts. Thus, the words pili nut are derived. According to the Department of Science and Technology, pili oil has always been featured in traditional medicines and herbal remedies in the Bicol region where it is found. Pili oil is being used by locals in treating skin disease such as scabies and deworming capability in livestock such as chickens and pigs. We decided to pursue this study because of the anecdotal statement of an entrepreneur in Sorsogon City about the antibacterial capability of the pili oil. She saw the potential of pili when she had field visits and discovered the Sorsogon abounds with the nut the whole year round. She noticed that the wounds start to heal in a few days, so she assumed that the oil of the said nut has antibacterial property. This has motivated us to conduct a study with regards to this assumption. The research work primarily aimed to investigate the antibacterial property of fixed oil of pili nut, Canary Tobacco family Burseraceae. It is specifically aimed to 1. Determine the percentage yield of fixed oil in the nuts of pili. 2. Determine the constituents of fixed oil. 3. Analyze its chemical properties. And 4. Determine what concentration of the fixed oil exhibit antibacterial property. The diagram projected on the screen is a paradigm of the study. Pili nuts were collected in the locality of Gubat, Sorsogon during the months of June to August 2011 and were validated at the National Herbarium of the National Museum of the Philippines prior to the study. The oil extraction was done using the cold press method. The pili oil produced has been subjected to physical test, chemical analysis, and bacteriological assay. The physical test consisted of organoleptic and miscibility tests. Chemical analysis consisted of the determination of the different chemical properties of the oil, such as its specific gravity, refractive index, iodine number, peroxide value of oils, saponification value, unsaponifiable matter, and fatty acid composition. Bacteriological assay followed using the extracted pili oil. For the antibacterial screening, test organisms such as Bacillus subtilis, Escherichia coli, and Staphylococcus have been utilized. Using the bacterial strains of the mentioned organisms, the turbidity of the culture broth was adjusted with the aid of the 0.5 Mac/Lan standard. Mueller-Mainton agar was poured into sterilized petri dishes and allowed to solidify in a smooth base layer of uniform depth. Paper disc method has been utilized for the antibacterial determination. Using a septic technique, the assigned culture was wrapped into the respective plates. A straight plate technique was the studying method used to ensure complete plate coverage. Using a sterilized forceps, the positive control disc was impregnated to the solidified agar, as well as the paper disc which were dipped in the pili oil with the concentrations of 250 mg per ml, 500 mg per ml, and 1000 mg per ml. To facilitate the clearing of zones, the petri dishes were incubated for 24 to 48 hours. After incubation, the zone of inhibition was measured and were compared to the standard. On the screen are the recorded results that we have obtained from the experimental procedure. For the percentage yield of pili oil, 100 grams of the sample were used in 3 trials. 6.5%, 6.4%, and 6.5% were the percentage yields for the trials 1, 2, and 3 respectively. It had an average yield of 6.47%. The pili oil appears to be a yellowish-brown liquid with a bland odor. It was immiscible with distilled water and ethyl alcohol, and was miscible with petroleum ether. The results of the chemical analysis are comparable to the theoretical values. The oleic acid has the highest fatty acid content of 61.7%. The zone of inhibition elicited the treatments of Escherichia coli using different concentrations were done in 3 trials. The average zones of inhibition are 25 millimeters, 13.67 millimeters, 7.67 millimeters, and 6 millimeters for the positive control, 250 milligrams per ml, 500 milligrams per ml, and 1000 milligrams per ml concentration, respectively. The zone of inhibition elicited by the treatments of Staphylococcus aureus using different concentrations are as follows. For the positive control, 27 millimeters was measured for the first trial, 26 millimeters on the second, and 25 millimeters on the third trial, with an average zone of inhibition of 26 millimeters. The zones of inhibition of the concentration of 250, 500, and 1000 milligrams per ml were not apparent. The zone of inhibition elicited by the treatments on Bacillus subtilis using different concentrations are as follows. For the positive control, 35 millimeters was measured for the first trial, 32 millimeters on the second, and 33 millimeters on the third trial, with an average zone of inhibition of 33.33 millimeters. The zones of inhibition of the concentrations of 250, 500, and 1000 milligrams per ml were not apparent. Next, calculate the data and the results between the positive control and the pili oil of Escherichia coli in terms of zone of inhibition. The statistical treatment showed that there is significant difference with antibacterial property of pili oil and the positive control in terms of zone of inhibition. After analyzing the outcomes, our group concludes that the fixed oil from the nuts of pili exhibited antibacterial property. It was apparent with the result in the Escherichia coli bacterial strain, which exhibited 13.67 millimeters zone of inhibition on the concentration of 250 milligrams per ml. With this obtained records, the following are our recommendations. 1. Use other test microorganisms in determining the antibacterial effect of pili oil, whether they are acceptable or not. 2. Propagation and cultivation of the pili nuts must be enhanced so that more plant sources could be used for similar studies. 3. A dosage form should be formulated which best fixed oil. The fixed oil of pili should be made into an oral dosage form. And 4. Isolation of oleic acid from the pili oil is also suggested by the researchers. Thank you and good day.
Kuya Manny. Kuya. Huwag ka na lang.
Naguliras.
Good.